Okay, now we should be saying, now we should be hearing something. Okay, now we should
Excellent.
be saying, now we should be hearing something.
Okay, let's turn that off. Great. Welcome back, guys. So in the link of this stream / video, or whatever, whenever you're watching this, you go away, please. In the link, you will find, in the description, you'll find a link to the last stream that I did, where we build the Connect 4 game in Golang. If you have not seen that or followed along with that, I recommend you watch it. Otherwise, in this video, what we're going to do is we're going to make the Minimax algorithm to play that game. So that we'll basically have an AI playing against us. Now, if you don't know how the Minimax algorithm works, that is the algorithm I'll be implementing today in this video. I recommend you go on YouTube and watch a video about how it works. Not necessarily how to code it, but how it works, just so that you understand how it works, because it is a little bit complicated. I will try to explain it a little bit, but it's complicated, and I'm going to focus on coding it and implementing it in Golang today. So there's a link in the description to a video to help you understand the Minimax algorithm. I would recommend you go and watch that. We won't be implementing alpha-beta pruning today. Maybe I'll do that in a future stream. The reason why, I'm not sure I understand it fully. I understand it a little bit. I could definitely code it, because I could just copy and paste someone else's code, basically, with my fingers. So it wouldn't be hard to do that. I just don't fully understand like the nuance of the system. Admittedly, I didn't try very hard, but the point is I'm not going to be doing that today because I don't know it. So let's get started with our thing. So this is the thing that I made, I think. No, this is the Python version. This is my version of the thing. No. Okay, it looks like I closed that. So let's make a new window. And if you're following along based on the last tutorial that I did, then just open up your folder where you saved all the code. I'm going to do that for myself, and we're going to start changing that into making it the AI version. So where's all my stuff? Here it is. Tutorials, Connect 4. We're going to select this folder to open. My computer updated to Windows 11 this past week while I slept. I did not intend it to do that, but it did that, and now it's like that. So great. Everything looks a little bit different. Okay, so if you remember correctly, this is where we had left off. Oh no, I can't just run it because that won't do anything, because I have to go run everything. Oh, okay, sorry, hold on. I edited this folder, so let me just make it so that everything is exactly how we left it off. Okay, so this is how we had left it off. Everything is just in our folder. We have these 3 files. And this is the game. Red player moves, yellow player moves, red player moves, yellow player, until someone wins, and someone wins, and you turn it off, and then it's randomized who starts the next time. Let's see if we can, so, anyway, let's see if we could get it so that, okay, in this situation, the yellow player should play, and he is. Hold on, let's see if we can get it so that there you go, that's randomization. Okay, so that's where we're at right now, and also if you tie the game, I wonder if I can purposely tie. I'll probably just end up messing it up, honestly. I have to be careful. No, see, this would tie it, right? Yeah, so let's go here. And then this would tie it. Let's go there, and over here, and over here. No, okay. Anyway, I can't deliberately tie it, but anyway, if you do tie and you fill up the entire board, which is unlikely, it will say tie game. So we have these 3 folders. We have a player folder. We have the main folder where all the logic happens. So yeah, okay, right. The player folder just basically makes a struct that has the ID. Each player has an ID, which is how it's represented on the board, which is a 2-dimensional list. This is just a bit of review. Every player has a color, red or yellow, and then it has a victory phrase of like player 1 wins, player 2 wins. We have this constants thing that just has a few constants: the width of the window, the height of the window, the title of the window, the grid size, how big each circle is. Not each circle, but how big each grid that the circle lives in is. How many rows we have, how many columns we have, what the FPS should be, what the enemy empty value is. So like player 1's value is 1, player 2 value is 2, and the empty value is 0. We have a radius. This is the size of the circle, and then we have a background color, which is just black. And then the main file, this is where all the logic lies. So we have this main struct that has a few things. Is the game running? Is the game over? Did someone win, basically? Who the winner is, if there is a winner. What the board looks like. The board is this 2-dimensional list of integers. The integers can either have a value of 0, 1, or 2. If it's 0, that means that location, that like row location and column location is empty. If it has a 1, it means player 1 is there. If it has a 2, it means player 2 is there. Then the game also has these two players, player 1 and player 2. It keeps track of the players also in a list. I forget why I do that, but I think it has something to do with the draw loop. And the game keeps track of whose turn it is. When we initialize the game, we just initialize everything to be how it should be. The game is running. The game is not over. We're initializing the Raylib window. We're setting the FPS. We're making our board into this empty thing. Everything is initialized as 0, which is correct. Everything should be initialized as empty. We make our player 1, who has an ID of 1, a color of red, and the victory phrase is player 1 wins. We have player 2, ID is 2, color is yellow, victory phrase is player 2 wins. We have these two players in our players list, player 1 and player 2. The turn starts at player 1's turn, and the winner is starting off as empty. In other words, no one has won yet. This is the close function. This is basically just what we do when the game is over. All we do in the close function basically is just close the window. But in theory, you could add more stuff here. I don't think we're going to be doing that. The reset function basically sets the game to not over, like the game is no longer over. Resets the board to empty for every row, for every column. The board at row and column are empty. The turn should be randomized. Then here's our loop. In the loop, if the user closes the window, as long as the game is running, if the user closes the window, we should just exit out. If that does not happen, we should update and we should draw. What is the update function? If the game is over, in other words, someone won, all we should be doing in the update function is checking to see if the mouse button is clicked. If the mouse button is clicked, then we should reset the game and we should return. Otherwise, if the game is not over, in other words, if the game is still going on, we check if the mouse button has been clicked. If it has been clicked, we get the column that the mouse button is on using a function in the game struct. If it is a valid column, we get the row. We drop a piece. Depending on whose turn it is, that determines which color piece will be dropped. Then we check if someone won. If someone won, then we set the game over thing to be true, and we set the winner to be whoever's turn it is. The turn is either a 1 or a 2. And if it's a 1, then that's player 1, and if it's 2, then that's player 2. Then after we check if someone won, we check if the game is over. In other words, not the game is over, but we check if the board has been filled up. We do that by saying if the length of the game dot get valid columns, in other words, get all the columns possible that you could draw pieces in, like all the valid columns. If the length of that is 0, then that means that the board is filled up, and game over equals true, and the winner equals empty. And then otherwise, if no one has won and if the board is not filled up, then we switch turns, and we just make it the other player's turn. In the draw function, I don't know why I'm reviewing all of this. I suppose you could just watch the other video, but I just want to make sure everyone's on the same page. In the draw function, we just say that we're beginning the drawing system. We defer to end the drawing system, obviously. We clear the background. We draw this big blue rectangle just as our board. And then for every row in the board, for every column in the board, for every column in the row, the value of that column is just the board index row index col. And this could either be a 0, 1, or a 2, as I said. If the value equals empty, in other words, if the value is 0, then just draw a black circle. You see it by black. Otherwise, you should draw a circle with the color of g.player's index value minus 1.color. The logic is pretty simple here. Why is it value minus 1? Well, if the value is 1, that means it's player 1, which means in terms of g.players, that's index 0. And so we just minus 1 because that's how indexing works. And then we get the color of that player. And we draw that color circle. Then we draw a circle. Oh yeah, this is drawing the circle depending on whoever's turn it is. Again, this is not value, but it's g.turn minus 1. This is drawing the circle that you see up top that flies across the screen as we move our mouse. It's this circle right here, as you can see. Then, if the game is over, if the winner is empty, in other words, if it's tied and the board is filled up, did I even set that over here? Hold on. Check if board has been filled. Yeah, so if the board is completely filled up, then we set g.winner to empty. So if the game is over and the winner is empty, we print tie game with the color of white. Otherwise, we print that player's victory phrase with the color of the player's color. And then here are all the helper functions that just make it work. Get column, is column valid, get row, depending on the column, drop piece, get valid calls, check winner. Very good. So with that review, what I'm going to do is I'm going to make a new folder, and I'm going to say this is the player, or rather the original, orig underscore version. This is the original version of the game. And we're going to grab all these files and we're going to put that in here, in that folder. Does that work? Yeah. The reason why I do this whenever I'm making an AI project is I always make the game and then I store that in like the original version folder just because I want to keep it, and then I make a new folder and I call this AI underscore version. And this is where I program all the code for the AI. So with these two folders, I'm going to copy everything in this folder and I'm going to paste it into this folder because we're starting off with that. And now let's start transitioning this into the AI version. So we don't need to look at the constants, I think. One thing I wanted, well, we'll do that when I get there, but for the main function, now instead of having one system to determine player 1 and player 2, right now, if we press the mouse button, it doesn't really matter whose turn it is, everything works as it's supposed to. So I want to change that. I want to everything works as it's supposed to. No matter whose turn it is, it works for both players' turns. I want to change that so that it only works for player 1's turn. In other words, yeah, only the red player is the human, and the yellow player will be an AI. So if the mouse is pressed and g.turn equals g.player1.id. So I want to check to make sure that it's player 1's turn, and then we do that. Otherwise, else if g.turn equals g.player2.id, in other words, it's the AI's turn. So I'm going to make a comment. Where should I make the comment? I'll make the comment right at the top of the update function. Player 2 is our AI. You know what, I'm not going to make this comment because it's not always going to be like that. Sometimes I might want to have two AIs facing up against each other. We'll do that at the end to just see how two different AIs play against each other. So for now, player 2 will be our AI. So here, I'll do it over here. AIs move. And I'll do it over here. Human move. Okay. And I'm actually going to make this just a straight up if statement because I might want to comment all of this out, and I don't want it to break and I don't have to change that. So I'm just going to make this an if statement. So if the turn is player 2's turn, we don't have to check if the mouse button is pressed because it's just going to be an AI and it can do it by itself. If the turn is player 2's turn, then call colon equals rand dot int 31n. I believe we're supposed to get an integer 32. So this will return an integer 32 in the range of 0 to calls, not including calls, obviously, because that's how the rand int 31n works. So this will get a valid call. And even though I know that this will be a valid call, I still want to make sure. So if if g dot is call valid, yeah, that's the function, and then we pass in the call. If the column is valid. Ooh, actually no. Yeah, because what if we have a column that's completely filled up and this randomly selects from that column? So I don't want that necessarily. Just for now, I want to make sure that we have a completely valid column. So let me just make sure, let me just review. Is column valid returns as long as the column's in the appropriate range and that column is not completely filled up. That's what this clause over here is doing, making sure that column is not completely filled up. So I want to make sure that this is the valid column, and the best way to do that is to just say, as long as the column is not valid, pick a new column. So for not g dot call, yeah, it is call valid. For not g dot is called valid, and we'll pass in the column, then this again, and we're just going to keep on looking for a better column. Not column equals this time, but okay, not a better column, but a valid column. And then once we get the valid column, we'll get the row colon equals g dot get row. Now this is also how you implement AIs normally, and before you implement the AI, just implement it so that it's random. And then instead of making it random, later we'll make it intelligent. But for now, it's just going to be random, just to make sure that everything works. So row colon equals g.getRow based on the column. And then we'll say, I mean, I guess now we could just drop it, right? get the column, get the row, then drop the piece, and then all of this will be the same. So yeah, all of this will be the same from here on out. Command C. Yeah, I believe that's all the same. No errors. So we get the row, we drop the piece in the column in the row, we check if someone won, we check if the board's been filled, and then we switch the turn. Great. Now let's run this and let's see. Oh, okay. So I have to CD now into. You have to CD into the folder that we're at, because now we've made these into folders. So CD into AI_version, and then go run. Go run everything. Okay. So let's see. Boom, boom. So great. It's random. Boom, 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 boom. I win. Oh wait, what? Player 2 wins? That makes no sense. Because I won. Now, why is that happening? Let's try this again. Huh. That's weird. That should not be happening. Got the column, as long as it's valid. Check winner. If g.check winner. fmt.println quote player 1 wins. I just want to make sure that we're getting the right thing, and then we'll make sure why stuff is weird. Player 1 wins. Okay, so we are getting into this if statement. Over here. Yeah, okay, as long as it's this and not g dot over, and the game is not over. As long as it's the player 2's turn and the game isn't over, because in theory we could go through this if statement, the game will be set to over, then we'll go into this if statement, we'll do everything here, and then we will check to see if someone won, and someone will have won, and so we'll set the winner to whoever's turn it is, which happens to be player 2's turn. So that's not good. So good, that fixes that, I believe. See, it's good to check things, right? Player 1 wins. Excellent. Now let's see if I could figure out a way to make it that player 2 will win. So, boom. No, player 2, you're supposed to go into one of these places, please. No, stop. What are you doing? Okay, one more time. No, I won accidentally. Shoot, I'm such an idiot. Okay. There you go, player 2 wins. Okay, excellent. So everything's working. Whew. Okay, now let's make this intelligent. So, the minimax algorithm. Let's start talking about this. I'm going to get paint or something up. Paint. What the minimax algorithm does is imagine this circle is basically our board. This is a state that our board is in. The minimax algorithm says, okay, we could, in reality there's like, how many moves? There's as many moves as there are columns, so there are 7 columns, so there are 7 moves. The minimax algorithm will look at each of those 7 moves and determine which one will get it to a better board. So to simplify that, I'm just going to draw 2 lines instead of 7. And what the minimax algorithm will do is it will look at these 2 boards, then it will score these 2 boards, and based on which board has a better score basically, the score will be interpreted. There'll be boards that score negative and boards that score more positive, and one of the players will be the maximizing player, so it's always looking to increase the score, and the other player will be the minimizing player, and it will always be looking to decrease the score. If you're not understanding this, go watch the video in the description about the minimax algorithm, and then come back. I'm just explaining this very briefly. So, and if you did watch it, you should know that the minimax algorithm will look like a certain amount of depth. So it will keep going to a certain depth, and then it will backtrack. It will go recursive up. It's actually a recursive algorithm, and we're going to be implementing it as a recursive function, actually. And it will look, etc., until the depth or until it finds a terminal state. In other words, a state where the game is finished, right? A state where someone wins or when the board is filled up, etc., etc. So what we're going to do is we're going to start by only implementing one layer, only going one thing deep, okay? And then we'll start the minimax process. So let's make, this is how I want to do it. First of all, I want to collapse this. I'm going to make a new file. I'm going to call it move underscore finder dot go. And I'm going to make a new struct, and I'm going to call it move finder. So type move finder struct. There's no real necessary reason. What's wrong? Oh, right, I need to make a package. Package main. There is no real reason to make this a struct. It's not necessary. I just want it to be a struct because that will help me organize my code. There won't actually be anything in the struct. Like, I'm not going to have any variables or values in the struct. It's all going to be functions, helper functions, and etc. So we're going to make a function, func, and this will be star, I don't know, let's just call it f finder star. Okay, and this will be a type move finder, and we'll call this function get move. This is going to be a temporary function. I don't think we're going to have this for very long. Although this is going to be a long video now that I think about it. Okay, so get move will take in a board. It needs a board. It needs a board to judge and then get a move from. In 32. So the board will be of type, it's a two-dimensional list of type in 32. Excellent. And it will return. It's going to return something. It's going to return a column in 32. For now, just to get rid of this error, I'll return -1. Okay. So what this thing needs to do, first of all, it needs to have the knowledge of player 1 and player 2 values. So in the constants, I'm actually going to make under empty player 1 equals 1 and player 2 equals 2. And then actually in the main function, when I make the two players, the ID will be player 1 and player 2. I'm going to make these global constants because the move finder needs it. The move finder is going to need those values. Okay. So. Okay. So again, just to give it a little bit of an example, not a little bit of an example, just to explain things. Where's my MS Paint? The move finder is going to look at our board. Okay, and it's going to find all the possible moves. Okay, then it's going to pretend to do those possible moves, and the keyword I'm using here is pretend, because we can't actually do those moves on the original board because that will modify our original board. So we're going to have to copy our original board and then pretend to do all those moves. Understand? So let's change this thing to a ridge board. This is the original board that's being passed in, and let's make a new board. A board colon equals an int32. Great. It'll be, I don't know, board colon equals make. You know what? No, I'm not going to do it this way. I'm going to make actually a function. Okay, I ran into this problem when I was doing it myself. Go has a built-in function called copy, and it basically copies all the stuff from one array to another array. The reason why we cannot use this in our case is because when it's copying all that stuff from one array from our original board to our copy board, when it does that, what it's copying the individual arrays, like the little arrays inside of our big board array, and those things are, I forget the term, mutable or not mutable. Those things are, if you modify it in the copy, it will modify it in the original. That's the point. And so it doesn't actually work. So we're going to have to make our own copy function. And this copy function will return a copy of whatever board you pass in. So let's make this function. Func f star move finder. And this will, oh shoot, this needs to be in parentheses. And it also needs to be, oh boy, I made a lot of mistakes here. Okay, there you go. And this will be copy board. And this will take in a board, int 32, it's called board. Okay. Original board, I guess. Orig board. Because we're going to need to use this copy function several times. And b colon equals make a type int 32 with a length of length of original board. And then for I colon equals range b, b index I equals make with the length of original board index 0, just to make the rows. So we're going to be making a new board that has the appropriate amount of rows. This is the appropriate amount of rows, and this is going to be the appropriate amount of columns. And then copy. So on each individual row, on each individual thing, we can actually use the copy thing. We can use the built-in go copy function. So b index I, that's the destination, and the source will be, just makes this consistent, original board index I, and then the source is original board index I as well. And this will copy things appropriately. So great. So now we have our copy board function. We'll use this to copy our board. And now in our thing, board colon equals wonder how I should do this. For now, it will just be an empty in32 array. And then, okay, so additionally, we're going to need a bunch, this move finder struct is going to need a bunch of functions from our game struct. So let's just find all of them that it's going to need. It's going to need all the functions that we use for like getting valid columns, making sure it's a valid column, getting a valid row. So it doesn't need get column. It needs to know if a given column is valid, I believe. So this one. It needs to be able to get the row, so we're going to need this one. It needs to be able to drop a piece, so we're going to get this one. It needs to get all the valid columns, so we're going to get this one. It needs to be able to check for winners, so we're going to need this one. Great. Copy. So yeah, it's going to need all of those. And we're going to have to make some changes. Instead of it being G star game, it's going to be F star move finder. This is not the most efficient way to do it in terms of like lines of code, but I like it this way. That way we have these double things in different structs, but it works. Everything is consistent. So F star move finder, and F star move finder, and F star move finder. Oh my god, there's going to be so many errors. Okay. Okay. So not only do we need to make sure that's the case, but we also need to, instead of it being in each of these, oh my god, in each of these it's going to need to get in, it's going to need to pass in a board, because we don't have a saved thing of the board in our move finder, right? So like that. It can't be g.board, because in our game struct we had a value of g.board up here, or over here, or whatever. But in our move finder, we don't have that, because the move finder will never be working with a fixed board. It's always changing things. So each helper function needs to take in its own board thing and needs to judge things based on that. What is the problem? What's wrong? Expected type argument? Oh, sorry, I did this backwards. There you go. That's going to need to be the case over here. And it's going to need to be the case over here. Oh, there's supposed to be a comma here. And it's going to need to be the case over here. And over here. And over here. And that's it. And then we need to get rid of all the G things. So, no, okay, yep, over here, no G's dot board, nothing like that. And over here, no G dot board. Excellent. Is there an error further up that I missed? Yeah, it's just this one. That's okay. In drop piece, oh, there is no g.turn. There is no turn at all. This thing will be dropping pieces dynamically, so it actually needs to take in the piece that it's going to drop. Type of in32. I don't know if that's how you spell piece, but whatever. Piece. Yeah, that needs to be dynamic. And then over here, no g dot, no g dot. If f dot is column valid, and then this thing needs to take in a board, right? So board. Yep. What? Wait. What? There you go. Board. Excellent. Yeah, it needs to take in the board because our f.isColumnValid takes in a board as well. And then check winner takes in a board. No g.board, just board. In fact, I'm just going to copy this and put this everywhere. Oh no, I can't. I'm going to copy this and put this everywhere. So paste the simple board, paste the simple board, paste the simple board. Oh boy. This is, oh boy. Okay. I suppose we do have to do this. It's a little bit tedious. I wonder if it would be just faster to just... Ooh, and there's also a change we're going to have to make to this function as well. Because we don't, because in the game struct, we keep track of whose turn it is. So we're able to use this function and we know whose turn it is. In other words, we know who won. But here we don't necessarily know whose turn it is. So this function is going to not, it can't just return true or false. It needs to return the value of whoever won. That's important. Yeah, that's everything over there. Oh boy. This is absolutely excellent. This is exactly what I like doing with my time. Okay. Oh, we missed one. Over here, one 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 over here. Oh, we missed a few. Okay. Where are the more errors? There are more errors. There's an error somewhere here. Need to find it. It's right over there. But I don't know where there is. Oh, it's right here. Found it. Okay, now there's only one error left in this entire page, which is this guy, because we're not using this value. So we have all our helper functions. Yay! Oh no, we don't. We have to make changes to this guy. Okay, so not only you're gonna you're not gonna return a bool. You're gonna return an int 32, the value of whoever won. So if someone won here, just return that value, return that value, return that value, return that value. Otherwise, return empty. In other words, no one won. 0 will be the value of no one won. Okay. So we have no, we don't have our new board yet. We do not have our new board. So board, I don't know why I did an empty thing. Board : equals copy. No, f dot copy board. And oh, we never actually return anything here, right? Yeah, we never actually return things. So we have to return a new board. In 32. What did I do? In 32. Great. This is going to return the new board. So over here, return B. This will take an original board. Excellent. Now, for I : equals range. Sorry, hold on. Sorry. Valid calls : equals f dot get f dot. Do we not have an f dot valid calls? F dot get valid calls. Yeah, we have one here. F dot get. Excuse me. I want to use this function, please. Why isn't it autofilling? Something is up. Something is up. Someone's missing a bracket somewhere. Okay. Oh, since... Yeah, that was the problem. If I get valid calls and this thing needs a board, sorry. I get freaked out whenever it doesn't autocomplete because it usually means there's an error somewhere. But in that case, it was just because there were no colons. So what we're doing is we're getting all of our valid columns, and we're going to loop through all the valid columns, and we're going to try out each one of them, and then we're going to score the board, and whoever has the highest score, we're going to keep that column. So we need to keep track of the highest score. Best score : equals, and it can't be 0 because 0 is better than a negative number, so it's going to have to be math dot infinity, and if you're not using an IDE that just automatically imports, go up here and type in import math.infinity -1. In other words, negative infinity. So the best score is going to be that. And just to make sure, I'm going to type at the top of our thing here, because based on what I'm deciding here, player 2 is now the maximizing player. I just want to make sure that it's consistent. So player 2, we're deciding that player 2 is the player that wants to maximize the score. This is not the implementation of the minimax algorithm. This is just the implementation of basically one level of the minimax algorithm. So best score equals negative infinity, and best column equals rand, and again go up here and type in math/rand, rand dot int 32n, the length of valid columns. This will get a random, what's wrong? Valid columns. Oh, can't use that. We want an int32, huh? int32. This will get a random index. We then want to use that random index to get a random column. So the best column is just going to start out as random. Valid columns. Index, random index, essentially. Okay, so now we have a best score and we have a best column. So now let's loop through all our valid columns, try them all out, and see which one's the best, see which one gets a board with the highest score. We're going to have to make a function to score a board, by the way. That's going to have to be a thing that we do. And then based on that, we'll choose the best board. So now, instead of returning -1, I can guarantee that we'll be returning best column. We will always return the best column that we find, even if it's just random. Okay. So column equals valid columns index I. That's the column we're working with. We know that this is a valid column because the only way we get it is from valid columns. So row column equals f dot get row based on, what does this want? This wants a column and this wants a board. So we'll give it our board. In fact, you know what? Before we do this, every time we go to the top of this loop, we should reinitialize board to be a copy of the original board. Every time we do this, we want to go back and like reset our board and then try things out. So the board will need to be reset. Column is, valid columns should be the same because the original board is the same basically. So valid columns is good. We can always keep valid columns as it is. Row is call board. Excellent. And then we want to do f dot drop piece based on the, what do you want? You want the row column board piece. Row call board, and the piece will be player 2. We'll have the value of player 2. Because in this case, we're only trying to find the best move for player 2, so we're going to cycle through all the possible moves for player 2. It's not dynamic right now, but we'll make it dynamic in the minimaxing algorithm. In the minimaxing function. For now, we're just doing a get move function, basically. Okay, so score colon equals f dot score board, and it's just going to pass in the board. If score is greater than best score, in other words, if we found a better score, then best score equals, oh, actually, I want to make everything bigger, just because I watched my last video and I realized that things were very small, so I'm going to make everything bigger so you guys can see it. So best score equals score now. Oh my god, how do you guys, I can't see like this. Nope, best score does not equal score. Best score equals score. Thank you. And best column equals column. In other words, we found a better column. Okay, this is what the for loop will look like. This is it. This is the entire function here. The only thing we have left to do is make this function. The only thing. That's going to be a thing. So that's going to be a thing. So we're reinitializing the board to try out all possible combinations of, not combinations, all possible moves. We get the move that we're going to try out this time. We get the row we're going to try out this time, like in the for loop. We drop the piece, we score the board. If we get a better score, then we update the score, we update the column, and at the end we're going to send the column. So the next thing is like kind of the next function we're going to make is kind of the most it's the most important function in this entire struct. It's going to be the function that scores the board. And in the minimaxing algorithm, that is the most complicated, not complicated, but that is the most important part. You need to find a way to score a board. You need to find a way to look at two boards and determine which one is better, objectively. So we're going to do that now. Since it's so important, it gets the top. This is the top function. Func score board, and this is not how you make a function. F star move finder score board, and this thing, of course, takes in a board. That's like its whole point in 32, and it's going to be called board. Okay. Oh, and it returns return. It should be returning a float. There's no return statement. Float 64, I believe. Why float 64? Because best score is initialized as a float 64 value with math.infinity. So we're going to initialize scoreboard with a float 64, and we're going to start the score off by default as 0, and we're going to just and then we're going to return score. Return score. Great. Yeah. Okay. Fine. I mean. Now you're happy, please? By the way, get move is not going to be used here, so let's make that capitalized. What's the problem? It's not an error. It's just someone's complaining. Check winner. Yeah, we're not using you yet. Patience, please. Okay, so let's first see if there's a winner. First steps first. Did someone win with this board? Did someone win? That's the question. If Hold on. Here, winner, colon equals, f dot check winner in the current board. If winner does not equal empty, in other words, someone won, right? Remember in our check winner function, we said that it should return empty by default. If not, it should return this. So if winner does not equal empty, in other words, someone won. So here, check someone won. So if the winner does not equal empty, if winner equals player 1, then score minus equals, and this needs to be some absurd value, something crazy. Nope. Like negative $1 billion. Like the enemy player won. Like, of all things, that's not what you're supposed to do. Why is this negative, you ask? Actually, no, I want to make this plus equals a negative value. This is negative because player 2 is the maximizing player. So player 2 wants to get the highest score, which means that player 1 wants to get the lowest score. So this is good for player 1. Player 1 winning is good for player 1. So it gets a negative huge number. Oh boy. Else, if this doesn't really need to be an else if, but I want to make it an else if anyway because it's easier to read. Else if winner equals player 2. At least it's easier to read for me, and it won't be that much on computing power. Score minus, and it actually will be a lot of computing power because we're using a recursive thing that grows exponentially. So later on we could refactor this into just a simple else statement. You know what? I'm going to make it an else statement right now because the only way that there's a winner that is not empty, that is also not player 1, is if it's player 2. So let's just make this as fast as possible because the minimax algorithm is slow once you get to like a certain depth. Once you get like a depth of like 5, it gets really slow. So else score plus equals just the positive value of this. In other words, it's very good for player 2, right? Exactly. We're all good. Okay, now. So that's obviously the simple thing. If someone won, it's like that, right? Oh boy. Sorry, my shoulder is problematic. The next thing we should do is check if there's a tie. Yeah, we should really check if there's a tie. Check for tie. Because if there's a tie, we just want to return 0. In other words, we don't want to look at anything else. The only reason why we would want to return something that's not... Ooh, this is interesting. it is important if someone won. If the board is filled up but someone won, that needs to be returned as like someone won. If the board is not filled up and someone won, if the board is filled up and someone didn't win, that needs to be returned as someone did not win. In other words, 0, just return 0. So check for tie. So if the length of f dot get valid columns given the board is less than or equal to 0, in other words, there are no more valid columns, it's just a tie, then return score. Yeah, return score. Return the score. Why are we returning the score? Because if no one won, the score is still 0 and we'll return 0. If someone won, then the score is this value and we want to return that value. Great. Now we need to check other things. Actually, you know what? If someone won, we just want to return this. Return. Because there's no point looking at anything else if someone won. If someone already won, then it's over. Someone won. And there's no point in looking at anything else. Return that. And over here, instead of saying return score, let's just return 0. So this is just here. Game over values. If the game is over, we don't want to look at the board in detail. We just like, the game's over one way or another. These are the values in like, depending on how the game is over. Now let's see if the game is not over. Because certain boards are better than other boards if the game is still going on. So game not over. For example, let's take a look. Let's also check the chat real quick, see if anyone's here. Doesn't look like anyone's here. That's fine. So let's take a look. It is clear, it should be clear, I hope it's clear, that player 1 likes this. This is nice. Player 1 likes this because it needs one more thing. So if it has 3 in a row, it's happy. Similarly for player 2, this is pretty nice. 2 in a row is better than 1 in a row in any situation, right? So we should make it so that it values having things in, not necessarily in a row. If you have 2 things and a gap and another thing, that's also very nice. So it wants to have like, you want to be able to check clumps. And we have to, you know how in the, what do you call it? In the check winner, we go through like all the clumps. First we go like horizontal clumps and we check 4 situations there, and then we go vertical clumps. So we're going to do something similar, except this time we're going to check the clumps, and we're not just going to check if they're filled up. We want to check if like there's anything there at all. So let's implement this, and when I implement it, I hope it's going to be clear. So game not over. Check horizontal clumps. I wonder what I should call them. Like clumps is not a very good word. You know, I'm gonna cheat real quick. I'm gonna see what I call them in my other one. Where is it? Go finder. I just like how I called it in the other one. Yeah, I can't find it easily, and I don't want to spend very long here. So, I don't know. I don't know what to call them. I don't know what to call them. I don't know. Clumps, clusters, bunches, collections. I don't know. Check horizontal clumps. So, first thing we're gonna do is just say clumps, colon, not clumps, but clump colon equals. We're gonna call them clump. Clump colon equals make int 32 of a length of 4, because every clump is going to be 4 long, either horizontal, vertical, diagonal. It's going to be 4 long, and we're going to check all the clumps. So check horizontal clumps. So this is going to look very similar to our loop here. You know, I'm gonna hard code it from scratch. So for row colon equals range of board. So for every row on the board, for call colon equals 0, call is less than the length of board index row -3 call plus plus. Why -3? Well, I've explained this before, but essentially when we're looking at horizontal clumps, clump declared but not used. So then comment that out real quick. When we're looking at horizontal clumps, we want to check these, and then we want to check these, and then we want to check these, and then we want to check these, but we don't want to check these because there's nothing here. So that would throw an error. So we only want to go until this would be the length, length -1, length -2, length -3. We only want to go up until here. Yeah. And similarly with the vertical stuff, we're going to do something, and then once we get up to there, we're going to go down the row and we're going to do the same thing. Similarly with the vertical stuff, we're going to start here, I guess, and we're going to check these, and then we're going to go down, we're going to check these, and then we're going to go down, we're going to check these. So it's going to be one column, and it will be the rows -3, right, and the vertical stuff. So let's actually implement that for loop right now. For call colon equals range of board index 0, so for every column in the board. And then this will be the same thing, except it's going to be rows. You know what? Actually, I don't like this. For row colon equals no, never mind. Yeah, no, never mind. I like it. I like it. So for not call, but this time it's going to be row. Not call, but this time it's going to be row. Not the length of board index row, but rather the length of the board in general, -3, and then row plus plus. And this will be for the vertical stuff. Oh boy, that makes no sense. Vertical clumps. And then we're going to do something similar for the positively sloped diagonals, which I'm not going to implement yet, but the point is we're going to do something similar. So now what we're going to do is we're going to populate our clumps array, and then we're going to check our clumps array. So clump, I'll do it this way, for I colon equals range clump, clump index I equals board index row index call. Okay, why is this true? Well, we're going to go through our board. We are going to go through our board, and when we're looking at the horizontal stuff, each one of them we're just going to put into the clump temporarily, and now we'll evaluate the clump. So now that we've populated our clump, populated clump with the values we are populated clump, whatever. We're populating the clump with the values we're currently looking at, and now we're going to evaluate the clump. Eval clump. And since we're going to do a very similar thing for evaluating each clump, I'm going to make it its own function, and this function will be called eval clump. So func f star move finder eval clump. This will take in a clump int 32, and this will return an int 32 of like the evaluation. We've evaluated our clump. For now, I'll just return 0. Okay, and excellent. So over here, right, we have a score thing up here. So up here, score plus equals f dot eval clump. Yeah, float 64. Actually, no, yeah, that makes sense. Let's just make this return a float 64 by default. Float 64 of the evaluation. And then up here, instead of saying float 64, we could just say f dot eval clump of clump. Now let's make the eval clump function. And in fact, the eval clump function is going to need its own function that we're going to have to code. I think. Yeah, it's going to need to. So okay. Yeah. What we want to do is we want to count how many player ones there are in that clump. We want to count and see how many player one values are in the clump. then we want to count and we want to see how many player 2 values are in the clump. And we want to compare that with like how many empty values there are in that clump. And so if there's 3 player 1 values and an empty value, that means that it's like basically a 3, and there's an empty spot, which is good because player 1 could go there and like win. So if there are 3 player 1 values and an empty value, that's really good. If there are 2 player 1 values and 2 empty values, that's really good. If there are 2 player 1 values and an empty value and a player 2 value, that's like not so good because that's never going to lead to a victory. So we need a count. We need a count function. Func. Because there is no count function in Golang that I know of that like works like that. There's a built-in Python function like that where you could count how many values there are, but there's nothing like that in Golang. So we're gonna need this because we're gonna be using this a lot. Count clump. I don't know. Let's just call it count. Let's just call it count. Count's fine. And this is gonna take in 32, and it'll be called a clump. It'll be called clump as well. Clump, and it will return in 32. Okay, now. Oh, and it also needs to see the value that you're counting for. So value. So it's basically going to take in the value and the clump and return how many of that value there are. So C : equals 0. And then it's going to return C. Return C. And now we'll loop through the clump and we'll count how many of those things that there are, and we'll just increment C. This is a classic counting algorithm. You should have learned this in like your first year of computer science. If you took computer science, I didn't. I just learned from YouTube. Not that I'm bragging, I'm just saying like it's basic stuff, so let's just do it. For I : equals range of clump. If, and of course I'm probably gonna get this wrong somehow. I'm gonna throw an error or something just because I bragged that I know it. I bragged that I know it. If clump index I equals val. Oh, sorry. Val should not be. It has to have its own thing. In32 equals val. Then C++. Excellent. And then we're going to return C. Why is this problematic? So, okay, it wants to be a int32. Val var C int32 equals 0. Great. Okay. So now in our eval clump, great. So now we're going to use this count thing in our eval clump. If count f.count clump, comma, not clump, but rather player 1, because that's the value. So let's just see how many player 1s there are in our clump. If the count of player 1s equals 3, and the count of clump for empty equals 1. In other words, there's one empty thing and there's 3 player 1 things. Then return negative. It needs to be negative, right? Because this is the minimizing player. Negative, I don't know, 10. Random value, just pulled that out of my head. Now we'll check the opposite. Here, else if, and I want the same condition basically. And also the same logic, basically. Else if, but instead of player 1, it's player 2. And then instead of, I just want 10, then I want it to return 10. And then now we'll do the next thing. So, like, what if it's not 3? What if this time it's 2? And the empty thing will be 2. And this is player 1, again. And then I want it to return negative, I don't know, 5, right? It's not as good as having 3 in a row, but it's pretty good. Having two in a row is pretty good. Else if the count of, okay, and now this is going to be player 2, 2, 2. So now it's going to check the same thing for player 2, and this will return not 10 but 5. Okay. Okay. I'm just thinking it might be that player 2 needs to emphasize not letting player 1 get a low score. But that's a story for another time. For now, let's just implement this simply. So now let's check the next thing, which would be 1 in a row. Not sure if this even has like a, I'm not sure if this is even a thing. I don't know, let's just give it a negative 1. Player 1. And then else if player 2 equals 1, and the empty is that, then return 1. And then if it's not finding anything, in other words, if this if this clump is like empty or if there are multiple colors in it, then just return a 0. The clump is like worthless. It's not even worth taking into account, basically. I mean, it is probably, if you want to make a more intensive clump scorer, then it is probably worth taking into account, but for now it's just not. So wonderful. Now in our, so we made this eval clump thing to use it over here. So we're going to look through all of the horizontals, we're going to evaluate each clump, and we're going to add whatever gets to the score. And now let's do the same thing for the vertical. There's an error here. Not just this, because that will just be the same thing. Column plus 1. We're looking through the horizontals, so we're going to increment the column. I noticed that when I was trying to copy this logic to the vertical stuff, because we don't want that. In the vertical stuff, we want the opposite. We want the row plus 1, right? Yeah. And then we're going to do the same thing basically. We're going to populate our clump, and then we're going to evaluate the clump and add that to the score. There's an error somewhere because something is not matching up with something. I don't know. Not sure why you're here. Anyway, so that's the vertical, right? Yeah, we made this so that it would be like that. Yeah, that's the vertical. And now let's check the negatively sloped diags. I do negative first because positive y values are like down in Raylib as well as in Pygame. So the negative slopes has the negative slope has the limitation of both the horizontal and the vertical. So for row colon equals 0, row is less than the length of. No, instead of saying length of, let's just say row is less than rows minus 3, and then row plus plus. For call colon equals 0, call is less than calls minus 3, and then call plus plus. So what we're doing is we're checking each row and then every column in that row, and then we're moving down the row and checking every column in that row. Hold on. No, we're checking each row, checking it like that, and then moving over, checking it like that, then moving over, checking it like that. And we're going to add that to the clump, essentially. So this is going to be the same stuff, the same code, except now, instead of adding to the row, we're going to add to the row and the column. And that's how we populate this clump. And now we have to do the positively sloped diagonals, which are going to be very similar to the negatively sloped diagonals, just the reverse. So pos sloped diags. Row is going to start off not at 0, but it's going to start off at rows minus 1. And I always forget how to measure this. So as long as rows is greater than, okay, let's see. This would be rows is greater than or equal to 0. So this would be rows is greater than -1. Okay, rows is greater than -1. Rows is greater than 0 would get me to here. Rows is greater than 1 would get me to here. Rows is greater than 2 would get me to here. So I want as long as rows is greater than 2, I believe. Where am I? Rows is greater than, I'm going to say greater than or equal to 3. Why that? Because I want the 3 value. I like that it's consistent like that. So let me just make sure this is true. This would be rows is 0, rows is 2, rows is 0, 1, 2, 3. As long as rows is greater than or equal to 3. Yes. Yes, that's good. Okay, good. And then we want the column constraint is the same because we're still moving from left to right. Instead of being row plus 1, it will be row minus 1 because we're moving up at this point. And instead of row plus plus, it's row minus minus. We're going like down the rows, and we're going down, up. It's all confusing, but basically, minus over here. That's how we populate the clump. Then we evaluate the clump. So there you go. That's our evaluate board function. This is how we score the board. This is how we score the board. We're going to use this in our minimax function, so this is important, this function right here, like I said. And so now it adds whatever value it gets from the eval clump to the score, and then in the end it returns the score. And we do that both for the horizontal, for the vertical, for the negatively sloped diags, for the positively sloped diags. And then it returns the score. Great. This is our evaluate clump. I believe this is correct. Let's just make sure this is good. Player 1, 3, empty, 1. Player 2, 3, empty, 1. Player 1, 2, empty, 2. Player 2, 2, empty, 2. Player 1, 1, empty, 3. Player 2, 1, empty, 3. And then negative, positive, negative, positive, negative, positive. Good. That's good. I think that's good. So that's the eval clump. Count we don't need to look at. Copy board we don't really need to look at. Great. So now in our get move thing, we get the score. Score is f.scoreboard. Okay. I think that's done. I think that we have the get move function ready. So we could actually implement that now. So over here, move finder. It's going to be of type move finder. And then here, g dot move finder colon equals a move finder. What's wrong? Expected identifier on left side of colon equals what? Don't understand what the problem is here. Okay, instruct move finder. Oh. What's the problem here? What's the problem here? Expected identifier on left side of colon equals syntax. Oh, when you're doing stuff in structs, you don't need the colon equals. Okay, good. So now, instead of getting a random thing for the player, for the AI's move, instead of getting a random thing, column colon equals g dot move finder dot get move given the board g dot board. Okay, and then let's just make sure it's a valid column. We don't really need to do this. It's not important. We get the row and then drop the piece. Okay, let's see if this works. As long as we coded everything, it should work. So, okay, that's good. Why is that good? Because not everything filled up. Sometimes everything fills up, and that's because you don't copy the board properly. So not everything fills up. Now let's see if the AI recognizes the value of having 3 in a row. It doesn't. It let me win. That's not good. What if I stop its progress and then get 3 in a row? Nope, still let me win. Oh, that's because it's not minimaxing yet. It's not looking several moves ahead. Because when I put down the third thing, it liked this move. Basically, it's good enough that it's trying to finish its completion, I think. No, it's literally just doing the first thing possible and then moving on. That's really weird. That's super strange. Huh. Yeah, that's really strange. I don't think that should be happening. I'm not sure what should be happening, but I don't think that should be happening. Let's fmt.println found. Hold on. Found better move. Let's just see if it ever. Nope, it always finds one better move. Why is it that going here is better than going here? This way is better because it gets a 2 in a row. So the AI should want to go here. Something is not working because it values 2 in a row. It should look at all the possible things it could do, and then it should say, oh, this one has a 2 in a row. I want to go here. But it's not doing that. And also it's weird that it's only finding one better move every time. Found better move. And then let's just print out the score it gets. fmt.println score. Zero. It's always 0. It never finds something better than 0. Hold on. In f.scoreboard. Ooh, I think if the length of f.getValidColumns of board is less than or equal to 0. Is this always running? Nah. It can't be that this one's always running. fmt.println tie game. Can't be that this is it. This isn't the error. No, that's not the error. Good. Okay, good. Because I have no idea how to fix that if that was the error. Let's check the stream real quick. No, no one's here. Okay, fine. How long have we been going so far? It has been an hour. We still have a lot to do, to be honest with you. Hold on. Yeah. Okay. Okay, so what's the problem? For some reason, the score isn't being evaluated. Hold on. What if there's a situation where the player 2 should win? Is it returning a score of we won? Okay, no, okay, good. So at least it's returning that. So there's something wrong with our clump system. Our clump system is never returning anything. Score plus equals f.evaluate clump. Wait, no, this should still work. For some reason, it's always just returning 0. None of these are ever coming to existence. fmt.println hypothetical 3 in a row found for player 1. Because that's what this means. It means that there's a hypothetical 3 in a row that it found for player 1. So let's see, 1, 2. It's not finding any hypothetical. That's weird. Okay, so there must be an issue with our counting system. Count. Of course, I knew I would get this one wrong. If clump index I equals val. Hold on, let's first get rid of this. C++. This should work. I don't know why this isn't working. fmt.println found something. I don't know. I'll just type in hey, just to know that it is finding something at least for something. It is finding something for something. Hey, okay, no, so it is finding a bunch of stuff. Yeah, as I expected. As I expected. How about How about in our main thing, just to test out our count thing, in our main struct, in our game struct, just to test out our counter thing. When I come over here, I want to fmt.println g.movefinder.count for a list that has like 0. Oh, hold on, I'm sorry. It needs to count to get a value of 1 for a list, an int32 list that has 0. Sorry, I always do this wrong. int32 that has 0, 1, 0, 1. And this should print out 2. We should get a printing of 2. Yep, okay, it printed 2. So the count system is working. Count system's working. How about 0? This should also print out 2. Also not so sure why there are so many gaps here, but whatever. That's not important. So yeah, so the count function that we have is working. Excellent. This is where you learn everything. This is where you learn how to code, right here, figuring out debugging. I'm a terrible debugger, I'll be honest with you. If count of player 1 clump equals 3. Maybe there's an issue with how we're populating our clumps. Yeah, maybe that's the problem. There's probably a problem with how we're populating our clumps. Clump index I equals. Yeah, it should have a range. It should have a length of 4. Size. Yeah, it should have a size of 4. Clump index I equals board index row index column plus I. Plus I. That's the thing. Okay. That's the issue. Okay, not +1, but plus I, because like I don't know. It's hard to explain this just because I'm not going to explain things. But basically, what we had before when it's just +1, that was always the same value. This is always the same value. This thing right here is like basically the same value. It's like the second element in our strip. It's like the second column of our horizontal strip. We don't want that. We want the first one, then the second one, then the third one, then the fourth one. So it needs to be plus I. It needs to increment with our clump. And we get I over here. The I element of clump needs to be row, column, plus I. This is why it's helpful to have a chat, because chats would notice that in a second. Row, index. God, I can't believe that was so stupid. Can't believe I was so stupid there. Okay, that should do it. There we go. Unbelievable. Can't believe that. Terrible, terrible, terrible. Now I have a bunch of print statements somewhere that I have to find and delete. FMT. There shouldn't be anything here. Okay. Don't want anything here. And yeah, okay, fine. That's that. And over here, it's okay to have 2 FMTs because that's just okay. Excellent. So there you go. We got rid of all our print statements. Now let's do this again. Unbelievable. Okay, this should work now. So there. Okay, interesting. It doesn't want me to get 2 in a row, I guess. I don't know. I'm thinking too much into it. Oh, it's not trying to stop me to get 4 in a row here. That's very weird. It should be trying to stop me. It should also be trying to get 3 in a row here. What the heck is it doing? What are you doing, AI? I don't know what this is. I don't know what this is. I'm sure. I assume it's still a problem with how we're populating our clumps. Let's see. Okay, horizontal. Row, column, +1, plus I. I made the same mistake again. In my head. Row plus I. Yeah, that's for the vertical and the same column. Yeah, very good. Row plus I, column plus I. Yeah, that's for the negatively sloped diagonals. Very good. Row minus I, column plus I. Yeah, that's good for the positively sloped. Okay, so looks like we are getting the right clumps. I guess. Whoa, boy. This is why it's helpful to like implement this stuff piece by piece before we implement the entire minimax algorithm, because it would be so hard to debug this stuff with the entire minimax algorithm. It would be so hard. It's hard enough as it is, honestly. I should have implemented the horizontal and then the vertical by themselves. Should I do that? Yeah, I'm gonna do that. I'm gonna make it so that it only cares about the horizontal stuff for now. That will help me debug, I think. So yeah, it's only looking at the horizontal now as valuable. So it really should not. There, okay, great. So it didn't let me do it that way. But I'm still able to do it this way, unfortunately, simply because it's not smart yet. So, right, you're supposed to take control of the center, man. I don't know. If I go here, it should go here. Good. Okay, that's good. Take control over the center. Go here now. And boom, instantly it stops me from going there, I guess, because it found a possible 2 in a row for me. Not sure. And it didn't find a possible 2 in a row for itself, so the next best is just to stop me. If I go here, it found a possible 2 in a row for itself, so it went there. Problem is, if I go here, it found a possible 3 in a row for itself, so it went there, and that allows me to go with this one. So clearly, it needs to like weight me getting a 3 in a row as more important than itself getting a 3 in a row. Because if it's like, well, he has the possibility of getting a 3 in a row. Wait, no. Right, yeah, it's not mini-maxed yet. That's the issue. Once it's mini-maxed, it will start realizing that after it moves, I get to move. Right now, all it knows is that it gets to move. And so it's just going 3 in a row for itself and not stopping my 3 in a row, which already happened, really. So it needs to start realizing that after it moves, I get to move. And once it realizes that, it's going to be like, oh, I can't let this happen. So anyway, the horizontal is working. That's great. Now let's turn off horizontal and make sure it values vertical stuff. This is the best way of doing it that I can think of. Let's see if it values vertical stuff. So when I go here, right, so it stopped me from getting my 2 in a row. Excuse me, sir, but. So there you go, it stopped me from getting a 3 in a row. So the vertical stuff is working, actually. I guess it's only when you put them all together that stuff breaks. I don't know. This one's going to be harder to check. Negatively sloped stuff's going to be harder to check. Okay, let's see. Let's see if it values this. So it just let me get it to, oh no, because it's not even checking this one. We have to get up to a certain height before we even are checking stuff. Interesting enough, it's stopping me from getting that, even though it's not paying attention to the vertical stuff, so not sure why it's stopping me from getting that, but how do I even test this? I don't even know. I don't even know how to test this. Boom. Okay, so there you go. So it stopped me from getting that. I think it did that deliberately. I think. Did it just win on a negative slope? Let's see if we could help it win on a negative slope. I don't know why it went there instead of here. There is better than here. Let's see. Okay, it went there. It went there. Very good. You shouldn't have gone there. You should have gone here. Honestly, I'm upset that it won because it's not checking the vertical stuff right now. At least it shouldn't be. For rows colon equals 0, as long as rows is less than rows minus 3 rows plus plus. For column colon equals 0, column plus plus. Populate the clump. For I colon equals the range of clump. Clump index I equals board index row plus I index column plus I. That's good. Score plus equals evaluate clump. That's good. That's all good. This one, rows is greater than, yeah, that's good. Good. Minus I plus I, good. I think this is good. I honestly think that this function works. It could just be that when we put it all together, then the AI gets confused, because it's not sure. Let's see if we could like rationalize what it's thinking. So I go here. It stops me from getting a 3 in a row there. That's good. I go here. It likes the 2 in a row here because it doesn't realize that I'll get to go here. So it's like, oh, if I go here, I get a 2 in a row. If I go here, nothing really happens. So it doesn't really care. And again, it doesn't really think about the future of what's going to happen because it's not minimaxed yet. It's not thinking about any move after itself. So I think we're good. I honestly think we're good. And in fact, this AI is better than what we had with randomization. Why? Because this AI will realize when it's close to winning. When it's close to winning, not when I'm close to winning. So for example, right now, it should go here. Boom, and it does. And right now, it should go here, and it does. And then it should go here, and it does. So it knows how to get itself to win. It doesn't yet know how to stop me from winning. So that's good. Okay. Time for mini-maxing, baby. Okay, you should know how the mini-maxing function works. You should have watched the video. If not, again, this slide. So the minimax. Well, let's do it, and I'll explain it while we code. That's the best way to learn. So let's do it. I'm not sure what we are going to need, what we're not going to need. I don't think we're going to need this. I don't think we're going to need the. We're going to need this. We're going to need this. I don't think we're going to need the get move function. So let's just table this for now in our heads. Func mini max. Sorry, I got so excited to type that I forgot what I need to do. F star move finder minimax. Okay. So the minimaxing function, as far as I remember, takes in 3 values. It takes in a board. Sorry, hold on. Orig board in 32. It takes in the depth. In other words, how many times after me do you want to check? Like how many of these do you want to do? Where are we? Where are we? Oh, here. Depth, which will be a type in 32. And then, last but not least, it takes in maximizing. I don't know if that's how you spell maximizing. Maximizing. Sure. Player. Bool. Then it takes in like, are you looking for a move for the maximizing player or the minimizing player? Like, who should I be thinking about right now? And that's a Boolean. Either you are the maximizing player or you're not the maximizing player, essentially. And the maximizing player, as we have said, is player 2, is the yellow player. We've decided that originally, and everything that we've done is built on that. The scoreboard function is built on that. The evaluate clump is built on that assumption. Count isn't really built on that, but it's a helper function, so whatever. So anyway, we need to keep consistent with that. Player 2 is the maximizing player. Great. So in the minimax, what is the minimax function going to do? Well, the minimax function will, first of all, what will the minimax function do? I suppose it will check if the game is over first. So, in other words, first thing it's going to do is it's going to see, is the board that we're looking at a finished board? Are we done? Is it either a tie or did someone win? So let's check that. If, hold on, let's make this first of all. Valid calls colon equals f dot get this is the same problem that we had last time. F dot get valid columns given our board, original board. Now, and then winner colon equals f dot check winner given our board. Yeah, the original board. If, in other words, check if game is over. Check game over. Oh, sorry. Returns best column and best score. Not best score, but and score. Yeah, and board score. And board score. So this thing is going to have to return an int32 and a float 64, because the score that we're using, 64, float, hold on, int 32 and a float. Why aren't you auto-completing for me? I need your auto-complete. Oh, right, parentheses. Int 32, comma, float, yeah, 64. Okay, this returns the best column and the best board score. So in other words, it will return what score did this board get and what move should you play to get to that board, essentially. So, my back. My back has real problems. The only reason why we needed to return the column also is in the main thing when we are looking to find the thing. When we're looking to find, in the main struct, when we're looking to find the column to move, we need to get a column back. We don't really care about what the score for that column is, we care about the column. Meanwhile, in the minimaxing function, all we actually care about is the score. We're trying to find the best score. So it's funny like that. You need to return both of them though. You need to return the score and the column. So, if the game is over, in other words, if the length of valid calls is less than or equal to 0, or the winner does not equal empty. So, whoa, what happened? Okay, if the length of columns does not equal to 0, okay, then someone won. You know what, I'm actually going to break these into separate if statements because, yeah, because different things will happen. So, if winner does not equal empty, in other words, someone won, return f.scoreboard, return -1 for the column. In other words, doesn't really matter how you got here. I'm not giving you back a column. I'm just sending you back the information that someone won. So -1 for the column, and also f.scoreboard, just return the straight up f.scoreboard. No. Hold on. No. We're doing the same thing. If no one won or the board, if no one won or someone won, if it's a tie, in other words, no one can win, or if it's a tie or someone won, just straight up return -1, comma f.scoreboard original board. So that's if someone won. Oh wait, or if the depth is less than or equal to 0, or we've reached the end of our line in terms of our recursive calls. So just return the score of the board that we're currently on, right? Yeah, I think so. Yeah, and then the, why are all of you open? Close. Good. Close down. I don't want you. I don't need to look at you right now. I need to look at you, the scoreboard. So the scoreboard function will check if someone won and return the appropriate thing. It will check if the tie happened and it will return the appropriate thing, and it will check the clumps basically if no one had won, and it will return the appropriate thing. So yeah, so if like not game over, check reached end of line. Like we reached the end of the line in this recursive thing. Otherwise, now things are gonna get tricky. So that's like, this is the simple part. This is like, we're done with the function. Now it's recursion. Now we're gonna deal with recursion. So if maximizing player, are we the maximizing player? Well, if we are the maximizing player, then best score colon equals math dot infinity -1. So if we are the maximizing player, then first of all we're player 2, which I should put over here. Player 2. If you are the maximizing player, then the best score you found so far is -1. And the best column you found so far, best call colon equals we have the valid columns over here, so I need that. I need that. How do I get that? Right. Valid columns index. Not math, but rather random. Rand dot int 31, and the length of valid columns. And you need to be an int 32. I know. Okay, and now we're going to loop through all the possible columns that we could do, and we're going to minimax from there with a depth of -1 for for I colon equals the range of valid columns, call colon equals valid columns, index I, not colon minus, colon equals row colon equals f dot get row column, and we need a board. We need the board, and the board is not going to be the original board. The board is going to be board. We're going to make a new board each time. So up here, let's make our board copy. So let's just call this board colon equals treat int 32, and it's going to be empty for now. And then every single time we're in this for loop, the board needs to be reset. Board equals f dot copy board. And I need the original board, orig board. So now we copy the board, and then we get it from the board. We get the row from the board, and then we could say f dot drop piece at row comma call into the board, and then what's wrong? Not enough arguments. What else do you want? Oh right, we need the piece. So if you're the maximizing player, we're dropping player 2's piece. And then, this is the crux. This is the crux of the thing. Right here. This is it. Score colon equals f dot minimax. We're calling minimax right here. Minimax, and the minimax function takes in a board. So no longer is it the original board. Now it's like the new board. We're going to minimax the new board with a depth of the same depth -1. We're going down 1 depth. So we've already done that. And then the maximizing player is now not the maximizing player. So we're switching off turns. Oh, sorry. And the score is going to be here, underscore comma score. Because it's going to return the column, but we don't want the column. We know what the column is. We chose the column. That's the column. We know it. And so all we want is the score. And now we could say if score is greater than, because we're the maximizing player, best score, then score, not score, but rather best score equals score. And best column equals column. Excellent. Excellent, excellent. Best column equals column. Yeah, over here we don't need to initialize best column up down here. We can initialize it up here. Best. Actually, you know what? Var best call, and this will be of type what in 32? In 32. And then best column over here equals that. And then down here, all the way at the end of our function, all the way at the end of minimax, what we want to do is we want to return. Wait, is this what we want to do? I think so. We want to return best column as our column, and the score will be, I don't know, doesn't really matter, but the score is down here, right? Yeah. I don't know. The score could just be 0 for all I care. I think so. Because the only way we get down here is if we've I think this works. The only way we get down here to this return statement is if we've minimaxed all the way to the top, and the only way you could minimax all the way to the top is if you've made it to one of these, I think. Because this is the only return statement that doesn't involve a minimax call at some point. Like this return statement will definitely involve a minimax, because we're going to check if you're the maximizing player or you're not, else you're not. So this thing always requires you to call minimax. And so the only way to get here is if you've at some point gotten here and you've worked your way back up. So recursion hurts. I hate recursion. Oh my god, I hate recursion. Ugh. But I think it works. I think we did it. What's wrong here? This value of board is never used. Yeah, I know it's never used. I'm initializing it. Fine, I'll initialize it differently. Var board. There, rather me initialize it like that in 32. You happy now? Good, thank you. Okay, now, else, in other words, if you're not the maximizing player, if you're the minimizing player, then this is all the same. Except for a few key details. Instead of it being negative infinity, you start off at infinity, because you're the minimizing player, you want everything to go down, so like the best score you've found so far is infinity, which means anything else will do, really. Board is, yeah, copy it, column, yeah, very good, row, yeah, very good, player 1, because now you're player 1. Yeah, very good. If score is less than best score. Yeah, we're done. A little bit unceremoniously, but I think we're done. This is the minimax algorithm right here. I don't know if I should walk you through it or just let's try it out. So first things first, we're gonna erase this function. Get move. We don't need this anymore. Which of course throws an error back here because we needed that. But no longer do we need this. Now instead of calling this, we will call minimax. Minimax. And yeah, the g.board, but as well as also a depth of, let's say, 3 for now. And the maximizing player is true, because we're in player 2 right now. So let's see if this works. Oh my god, please work. Please. I'm begging you. There's so much here that could go wrong. Okay, let's just go here. Okay, now I'm going to go here. Okay, now I'm going to go here. And you're done. So, it didn't work. Okay, this is going to be tough. boy. Okay. Let's figure this out. This is gonna hurt because it's recursion. We check all the valid columns. The winner, we check if there's a winner. If there is a winner, or if it's a tie game, or someone won, or we've reached the end of the line that we're checking, then just score the board and return that score. Otherwise, I hate recursion. I hate recursion so much. If it's the maximizing player, the best score is initialized to be negative infinity. Right? Yes. The best column is initialized to be a random column. Good. For I colon equals range of valid columns, so we're looping through all the valid columns. Board equals a copy of the original board. Good. That's good. Column equals valid columns index I. That's good. We're getting whichever column we're looking at currently. Row column equals get row based on the column on the board. Excellent. Drop piece into the board with player 2's value at column comma row. Score colon equals f.minimax board depth -1 not maximizing player. Good. If score is greater than best score, then best score equals score. Best column equals column. Good. That's good. Okay, this all makes sense, I think. I think this all makes sense. Excellent. Okay, now let's check player 1. Best score colon equals math.infinity. Good. That's how it should be initialized. Yes, very good. Best column. This is how it should be initialized, right? Because player 1 is the minimizing player. Yeah, very good. Best column equals valid columns. There, very good. For I colon equals range of valid columns. Board equals f.copyBoard. Very good. Column equals valid columns index I. Very good. Row colon equals get. Okay, there you go. Very good. Drop piece. Player 1. Excellent. Very good. Underscore comma score, because we don't need the column. We have the column. We're the one that gave it the column. Minimax board depth -1. Not maximizing player. Excellent. If score is less than best score, yeah, very good. That's the condition you should be checking. If we got a lower score, if player 1 is doing better, then best score equals score. Okay, very good. Best column equals column. Very good. Okay, and then, last but not least, you should always be returning the best column. God dang it. I can't find what's wrong in the first pass, which means we're gonna have to get in there with print statements and figure things out. Okay, let's do it. Let's do it. Okay. First things first. Make it a depth of, I think, 1 or something. So, in that case, I never want this to happen. Player 1 check. I never want to check player 1 right now. I want a depth of 1, so let's just make sure that's happening the way I intended to. Great, excellent. So we have a depth of 1. Great. Okay, now let's just make sure everything here is working properly. So FMT, because I had problems with infinity before. Println best score. It should be initializing to negative infinity. Let's see. Negative infinity. Excellent. Now over here, let's fmt.println found better score, and then fmt.println no, that's good. This is good. fmt.println best score. I thought that I found an issue. I didn't. Let's see. Okay, found better score, -4, -3, -2, 3. So it is looking. It's looking. That's good. It's good. Okay, and it's finding the highest thing. It's always increasing. Excellent. What sucks is the fact that that's everything we could check for player 2. Like, player 2 is working. I know that now. Excellent. So, great. Dang it. Let's. This is gonna get more complicated now because I have to go into a depth of 2, and that's gonna mean recursion thinking, and I can't do that easily in my head. So let's go into a depth of 2, and now we should be looking at player 1. So fmt.println, looking at player 1. So let's see how many times we're gonna look at player 1. What will it be? It'll be a crazy amount. It's gonna be like something, yeah. Oh no, not actually that crazy. 1, 2, 3, 4, 5, 6, 7. Does that make sense? No. No. No, that doesn't make sense. No, wait, it does. It does. No, wait, it doesn't. No, it doesn't. That doesn't make any sense. Because for every single time we look at player 2, we should be looking at player 1 7 times. So this should be 1, 2, 3, 4, 5, 6, 7. 7 times. 7 times. It should be however many valid columns there are times however many valid columns there are next time. This doesn't make sense. Something doesn't make sense. Something doesn't make sense. Something doesn't make sense in player 2's code. For I colon equals range of valid columns. Everything needs to be inside this for loop, yeah? Yeah, everything is inside this for loop. Okay. Okay. So then what? This doesn't make any sense. Something is very wrong. Right here, this should be running many, many more times than it is. Oh, no, sorry. No. Yeah, this is looking at player 1 like in general. I think that what I'm looking for is this one. Yeah. Yeah, because for every move it makes on player 2's part, it looks at player 1 once. And so this is going to be the amount that I was looking for, correct? Yeah. Yeah, this is what I was looking for. What is that, like 7 times 7? Yeah. Okay, fine. So that's working, I guess. Yeah, I guess that's working. So that part's working. The recursive part is working, I think. So let's just check everything. Best score. Let's make sure that the best score is being initialized to infinity. That's how it should be, I guess. Let's see. Infinity, infinity, infinity. Very good. Excellent. That's exactly how it should be. fmt.println found better score, and then fmt.println score, or rather best score. I want to make sure that it's updating properly. I don't see how it couldn't be, but I just want to make sure. So let's make sure that player 1 is always getting negative. Yeah. The reason why this one's going back up is because I think that it's reached like the end of what it's looking for, and this is the next time it's looking down at stuff. Found better score, yeah. Found better score. Yeah, this is all working. I think that's working, yeah. Yeah, I think that's working. So then why is the whole thing not working? That's the question. Give me a second. I just first var best score float 64. I don't like having it like this. Equals best score. Good. Okay, I prefer that. Huh. If you're the maximizing player, that's good. Not maximizing player, that's good. Not max. Yeah, everything's working. Player 1, player 2. Let's check the board. fmt.println board. Let's check the board. Let's make sure that the board is being updated properly in the theoretical sense. So we go in the middle. And yeah, we go in the middle. It checks this. It checks this. It checks this. It checks this. Excellent. checks this, checks this, checks this. Yep, that's all working. So strange, so strange. So strange. Are we sure that it's not working properly? Are we sure that the minimax algorithm is not working properly? Sorry, hold on, no, not a depth of 2. I want a depth of like 4. Let's see a depth of 4. Let's see if it blocks like my attempts to win or something. Let's see if it could do it. Wait, what did I change? What did I do? It's working now. Why is it working? What? It just won. Wait a minute. Wait a minute. Wait a minute. What did I do? What did I do? I didn't do anything. See, it even stopped me from going up there. What's it thinking here? That it could trap me and win. What did I do? It works now. I was checking with a depth of 3 before, right? Maybe that was weird. Maybe that's what it was being thrown off by. Nope. No, it's working. What did I do? I didn't do anything. What the heck? I changed something here. Hold on. If I make this 0 again, as it was before, yeah, it's broken again now. That's what I changed. Okay, wait, why is this important here? What does this do? I completely messed up the minimax algorithm, but I don't know why this is important. I don't know when this is ever checked as like important. I don't know when this. Wait a minute. Do we back up with this as the thing? How does the minimax algorithm work? You go down and you check everything, and then you go down and check everything here. If this is like a finished game, then it just returns this value to this. It returns this value to this. If this is like, if down here was like the final depth, then those return this value to this, and this to this. So when these two send it to this one is neither a depth of 0, nor is this one a, this is not a depth of 0, nor is it a finished game. This is a receiving component of this one and this one. When it receives, when one of the minimax algorithms receives a score here, it stores that, and it uses that, and it needs that to send it back up the tree. This guy needs this to send it back up the tree, and that's what you're giving it. You're giving it the score to send it back up the tree. Because I was envisioning it as this one would always be the final, this return statement would always be the final return statement. It would be the thing returned by this. And so we don't need the score, we just need the column. But no, if the score is greater than 2, if the depth is greater than 2, if we're going more than just, if the depth is greater than 1, if you're going more than just one thing down, then these two are both receiving values from this. And what they'll be returning, these two will be returning based on this return statement. And so that's why you need the score, because this guy up here is also receiving from this. It's receiving the minimax of these, and so it needs the score. It needs to be able to compare the score, and I was always setting that score as 0. So that's weird. That's weird. Like, it's weird that I was always saying that score is 0, and so this whole thing broke. And so that's why this fixed it. That's crazy. Oh god, I'm such an idiot. I can't believe that I did this for aesthetic reasons. I just wanted this. I just didn't like the fact that we weren't returning stuff like this. I just wanted this. That I have no idea how long that would have taken me. I have no idea how long that would have taken me if I hadn't done that. Okay, I think we're done. Let me just check the chat. Nothing in the chat. Okay, so one thing that I want to do. How long have we been going? Is this like a 2-hour thing? Oh no, we've only been going for like an hour and 12 minutes. Oh, that's not so bad. This is updated, right? This is me. That was weird, maybe. That's what it was being thrown off by. This is updated. This is still me, right? Nothing in the chat. Okay, so one thing that I want to do. Yeah. Okay, so just we're done. We did it. It works. As you can see, the minimax algorithm is working. It's blocking me. It's attempting to win. In fact, I don't think that I could beat it at this point unless I got really focused, because it sees the whole board very well. So right now it's thinking this, but it's also thinking this. So I want to stop that. So I don't know why it's going there. To maybe make a three-way thing over here. What's this important for? It's gonna go here and then here, maybe? I don't know. There. So right now it's thinking for that. So it finished that so I could go here, but I'm not gonna let it. I'm gonna go there first. So anyway, that's the minimax algorithm. There you go, it just won. That's the minimax algorithm for you. Finished. One thing I want to do, two things I want to do. There's two things I want to do. First of all, I want to go to like a depth of 5, and let's see how long it takes. Let's see how long it takes for it to move. Basically instantly, right? Very cool. Let me show you the Python version I have of this. Yeah, this is the Python version. Let's run that. Oh shoot, I need to set the depth. Hold on. So yeah, this is the Python version. Where is it? I followed a tutorial from somebody. I'm not too happy with how he did his code, because he did it all not object oriented. I don't like that. I like object oriented programming. So let's see here. Yeah, over here. This is it. And yeah, okay. This is done in Pygame. So let's say a depth of 5 here. Let's see. I want to compare speeds between Golang and Python. Why is it running twice? Two things are running. Okay. I don't know. So I post my. Okay, so it takes a while, no? Yeah, it takes a while for things to go. Let's do a depth in Golang of like, I don't know, things could get out of hand really quickly, but let's do like something like 10. Oh my god, that's crazy. You know, like this will take a while, I'm sure. Yeesh. If it takes too long, I'll just close it down. So you see it's taking its sweet time. I can't even draw it because that's not how the game is built. The game is built to like calculate everything step by step. So, oh boy. Oh boy. Okay, this is taking way too long. One thing I'm going to do is return after player 1 moves out of the update function, just so that it draws it before it starts calculating for player 2. And I'm going to, yeah, okay, good. So let's move this back down to like 7, because 10 is way too much. So this should draw it now before player 2 moves, and player 2 is now thinking. This is player 2 thinking. Take your time, player 2. Okay, and it moved. So that was 7. That wasn't too bad, right? For Python, that would take a crazy amount of time, I'm sure. So let's see Python. This is just me geeking out because I love how much faster Go is than Python. I love Golang. I really love Golang. So that's, okay, this is a depth of 7 for Python. Let me just quickly move back to the Golang thing. Run this again. Because I bet that I could even get Golang to go before Python goes at this point. Oh, I can't even move it. Okay, let's see. Who's going to go first, Golang or Python? Boom, Golang went first. And I started it way after, remember? Python is still thinking, the poor guy. Ah, Python just went. In the time that it took me to get to Golang, load it up, Golang was able to go basically twice, and Python only went once. Yeah, Golang is crazy fast. Golang is so much faster than Python. Ooh, one thing we could do. Well, this is no longer fair, really. No, it is fair, because there's just as many valid moves, I think. Yeah. So, one thing we could do is we could actually compare it full on. Let's compare it full on. Let's get like a full comparison going. So, okay. Boom, boom. So this is the Python version, and this is the Golang. And I'm going to click somewhere on Python and quickly click somewhere for Golang. So boom, boom. Let's see. Python's thinking. Golang. Thought. Boom. So that's 1 for Golang. 2. 3. Actually, this isn't fair because it's... Okay, so Golang was basically able to go 4 times, but it's not fair because it does get to a terminal state quicker, I guess, in this case. But the point is, Go is like so much faster. I think we saw at least twice as fast as Python there. So excellent job, Golang. Very impressive. Now I want to make it so that AIs are fighting AIs. So let's give this person a thinking time of 5 depth, and let's do if g.turn equals player1.id, and then colon equals g.moveFinder dot minimax, and this will be g.board. The depth will be 5, and the maximizing player is false because this is player 1. Oh, column comma underscore because it's returning a score and a column. And then what's the problem? Oh yeah, we don't really use getColumn anymore for now. So let's see some AIs duking it out. Let's do this. Let's check it out in Connect 4. And they tie. Okay, there you go. So Connect 4 is a solved game, as you can see. Now, what's funny is let's see if we give one of them an edge. Let's see if this person is able to see 6 moves ahead. Now what will happen? This is funny. This is how I want to see. So yeah, player 1 is taking a nice amount of time to think. He's really thinking like a smarty pants. But I think the real thing is once you get to a oh, now that's interesting. Player 2 won. Player 2 won. Okay. Okay, wait. How did player 2 win? I'm having trouble finding it. I'm having trouble finding player 2's win. Anything here? Ah, here it is. Here it is. It's a positive slope. I think that this is a bug. I'll be honest with you. I think neither of them would have realized that this was going to happen. Like, there's probably a problem with how we're checking the positive slope diagonals, and so player 1 and player 2 probably both missed this, and yet it just happened out of pure luck. I'm almost positive that's the case. Let's check our thing. Let's check our positive slope diagonal calculator. That's funny. No, that's evaluate clump. Yeah, let's see how we're getting the positive slopes in. Let's see. For row colon equals rows minus 1. Row is greater than or equal to 3. Row minus. Nope, this is good, I think. I think this is good, actually. I think everything here is good. Row minus I, column plus I. That's so weird. That's so weird. Hold on. If player 1 is only able to see 5 moves ahead, but player 2 is able to see 6, what will happen? That's so weird that someone who's thinking more moves ahead lost? That's so weird. Player 2 wins again. Something's up. Why wasn't player 1 able to stop that win? Where did player 1 move last time? That he had to move, otherwise player 2 would win. Nowhere. Where did player 1 move already? If he moved here, then there's no player 2 winning anywhere here. If he moved here, there's no player 2 winning. Nothing here. If we run it again, it should be the same thing, because it's just computers. You notice how it speeds up, by the way, because they're reaching terminal states quicker. Yeah, it's the same exact thing. Oh, player 1 moved here. Why did player 1 move here? That was the last thing that he did. He moved here. Why? What was player 2 going to do? He helped player 2 win. Is he working to this? Does he think he'll get here? No, that makes no sense. He moved here. By the way, we basically finished the coding. Now I'm just trying to figure out like if this is a problem in the code or if this is just a feature. Like if this is just a part of the minimax algorithm. I find it hard to believe. I'm trying to think how this person could be thinking. As long as it's not a bug in how we're working here. When we score the board, if winner equals player 1, then return negative billion. If winner equals I think that makes sense as a scoring system. I think that does. I think that makes sense.
Is that being passed up? Is that value being passed up the line? In other words, does player 1 think that it's okay, player 2 will win, but I'll win after player 2 wins? No, it can't be. Can't be that that's what he's thinking. Because we don't check after that. We just return. We just get out of the function, right? Right? Wait a minute, right? We do, right? Yeah, we return. We return. We return. We get out of there. If someone wins, that's the end. You don't check anything after that. It's not like player 1 thinks that player 2 will win and then I'll win. Because if say this is where player 2 wins, then we don't check this stuff. This stuff is gone. So there's no way that player 1 is getting tricked up by that and thinking that he'll just help player 2 get into a path of victory so that he'll win. Winner does not equal empty. Or depth is less than or equal to 0. Winner equals f.check winner. Original board. Let's run this through with player 1's head. Winner equals f.check winner. So no one won, let's say. This is the move right before player 2 will win if player 1 does not make a certain move. Okay, hold on. Let's make this very clear. Player 1 is going to move here and help player 2 get this thing. Player 1 is going to move here and help player 2 complete this system. So he moves here, and that helps player 2 complete the system. So he makes the one move that will help player 2 win. You understand? He's making the one decision that will make him lose the game. What happens if player 2 moves here, huh? What happens if he doesn't move here? Let's say he moves the only other place he can move here. Then player 2 will move here, which won't win player 2 the game. Then he'll move here, which will allow player 2 to win, or he'll move here, which would allow player 2 to win the game. Player 1 is stuck. Player 1's been trapped. He can't move anywhere in this position. In the position where these two circles aren't here, he's dead. He's dead in the water. Because if he goes here, then player 2 will go here. First of all, if he goes here, player 2 wins. Right? If he goes here, then player 2 goes here, threatening this. Threatening to go here. If he tries to block that, player 2 will go here. Right? Which will make it win. So he doesn't want to block it, because then player 2 will win, so he moves the only other column he can move, which is over here, which is then going to be over here. And then player 2 will move here and win. That's fascinating. It's fascinating that he could walk himself into a trap like that, even though he's thinking moves ahead. I guess there's always a threat. What the second player to move in Connect 4 has an advantage? Is that what we're learning here? That's insane. Hold on. Is thinking 6 moves ahead the key? Because before when they both thought 5 moves ahead, this is amazing. This is incredible. This is crazy fun. Hold on. When they were both thinking 5 moves ahead, they tied, right? Yeah, they both tied. But when one of them started thinking 6 moves ahead, when either of them started thinking 6 moves ahead, player 2 won. That's so weird that when player 1 is thinking 6 moves ahead, player 2 will win. That's wild. That's wild. That's absolutely wild. Is 6 moves the key? Like, if they both think 6 moves ahead, then will player 2 win? Or will player 1 win? Or will it be a tie again? Because if they're both thinking the same moves ahead, then it's a tie. This is going to take a little bit more time. We're going to have to sit back for a little bit. This is absolutely wild. Someone should, you could write, it's a tie game. Oh my god! You could write, a master's thing on this phenomenon that we're seeing. This is insane! Hold on. It's a tie game if they both think the same moves ahead. But if... I want to see something. What if player 1... No, what if player 2 thinks 5 moves ahead, but player 1 thinks 4 moves ahead? Will player 2 win? That's what you'd expect, right? It's thinking more moves ahead, right? Player 2 wins. Okay, that's what you would think. Yeah. What happens if player 1 thinks 5 moves ahead and player 2 thinks 4 moves ahead? Will player 2 win? What? What the heck? What the heck? What the heck? That's so weird. Why is this happening? What if they both think 7 moves ahead? It's either a tie or player 2 wins. That's what we're seeing so far. Player 1 never wins. This is going to take a long time. Oh boy, this one's going to take a while. Sit back, everybody. This is wild. This is absolutely wild. I can't believe what's happening here. No, come back. Thank you. This is going to take a long time. Where are you going to go? Player 1. Okay, where are you going to go? Player 2. I recommend here. No? Okay. Ooh, we got to stop this from happening. Ooh, player 1, you got to stop this from happening. There you go. Good boy. Okay, things are speeding up now. Very good. Because there's... Player 2 wins. Okay. Kind of what you'd expect, right? No, not what you'd expect. No, not what you'd expect. Oh my god. Because before we had an axiom. That if they both thought the same moves ahead, they would tie. But if one of them thought more than the other, player 2 would win. Now we have them both thinking 7 moves ahead, and player 2 wins. I don't understand what's happening here. I actually don't. This is wild. This is so wild. I don't know. Alright, let's see like a total idiot's fest. If they both think 1 move ahead, let's just see what happens. They're both just thinking their move. This will be really quick. Player 1 wins. Ah, it's the only way player 1 could win. What if they both think 2 moves ahead, huh? I guess, yeah, when they only think 1 move ahead, whoever moves first has the advantage, right? But if they both think 2 moves ahead, then player 2 wins. Yeah, it's whoever starts first. Whoever starts second, rather. Which is randomized each time you start. They both think 2 moves ahead. If they both think 2 moves ahead or 7 moves ahead, then player 2 wins. But I don't. What about 3? Is this gonna be a tie? When do you finally start getting ties? No, that's player 1. That's player 1 winning, guys. Player 1 won with 3 moves. 4. Player 1. Interesting. And I believe 5 was ties. Seems like in like the lower numbers, player 1 is the king, and in the higher numbers, player 2 is the king. I don't know. Maybe it's like when you get to maybe if you get to like 11, then it will start being player 1 again. I don't know. 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 I don't know the answers. I don't know the answers. This I would totally. If I could make a master's on this, I would. Okay, that's the end of the video. But obviously there are things you could do. For example, you could weight the middle. You could make it so that the middle columns are worth more. That's the first thing you could do. Because middle columns are better generally because they maximize like your chances of verticals and horizontals and diagonals. So middle columns are better. You could weight those and make those more desirable. That's one thing you could do. You could also implement alpha beta pruning. Alpha beta pruning will make the entire process of finding the best move shorter. I'm not sure if I fully understand it, so I didn't include it in this video. Maybe I'll include it in a different one. Beyond that, you could just think about different ways that a given Connect 4 board is desirable and implement that. I don't know if I'm going to make any more videos in this topic. I might. I genuinely might. I might make one about alpha beta pruning and just making the scoring function better, but I think the video has gone on long enough for now. I'm going to talk to my brothers about this this phenomenon that we're seeing here, about who's winning and who's not, because I think it's just way too fascinating. And they're both very good at math, so I'm sure they would have insights. Anyway, until next time then. See you guys around. I'm gonna stop the stream. And yeah. Oh, sorry. Yeah. So that's there you go. Bye. I hope you guys enjoyed. Sorry, hold on, wait. Any questions in the comments? Happy to respond. Hope you enjoyed. Hope you learned something. Very interesting stuff. I think we've seen some really interesting stuff, honestly. So, good work today. And oh, look, you can see how long it's been right up here. Good work. Keep trying with Golang. It's a great language. My favorite language. I don't know. Python's pretty good too, but Golang is very special. Hope you guys enjoyed. I'll see you around. What else? Is there anything else? In the description, there's a link to the original video that inspired me to make this video. That one's in Python from some other guy, from someone else. Give that a watch. Give that a like. Leave him a comment. I don't know. Give him some love. Other than that, yeah. Any questions, comments, ideas in the comments. And I hope you enjoyed what we've done today as much as I did.